Are you here?
Yes,
Online
can you hear my voice?
Okay, the stage is yours. Let's start. Thank you.
Okay, I should share my slides right now. Let's see. Okay. Now you should see my slides, okay? Okay. Hello, everyone. I'm Shinta Sato, working for JPRS, which is the Japanese CCTLD company, which operates en-route servers with wide project. So today's my presentation is about en-route DNS update after 6 months deployment, which means that we have deployed new servers in Bangkok for 6 months. So I'll start with the basic information of the root DNS servers. So everyone know about the domain name. However, the root DNS servers are the servers at the root or top of the DNS hierarchy, which will introduce information of the root zone. This provides the DNS service for root zone, and it's which is the very globally unique zone name derived by IANA, managed by IANA. And the root service, it is very stable, reliable, and resilient systems right now with operation with integrity and ethos. So root DNS server, that is the very important service for using the domain names. Right now, there's 13 root servers in the world, which is named as from A root servers or B root through M root. That is the 13 names of the root servers, and it is operated by 12 independent organizations right now. Actually, VeriSign operates A root and J root, so it's not 13. And as you can see from this slide, many root operators are basically located in America, United States. However, iRoot, NetNode, KRoot, RIPE-NCC, and mRoot, Wide Project, and JPRS, that's only three of them is located outside of United States. And mRoot, this is the only operator based in AP region. So how many root servers we have around the world? Last year, I made a similar presentation, which was explaining about the mRoot is coming to Bangkok. At that time, I was saying that there is about around 1,600 root servers around the world. However, right now it is almost 1,700 root servers around the world. It is increasing, still increasing, sometimes decreasing, but it's almost increasing constantly still. And mRoot, talking about the mRoot, mRoot is one of the not so much deployed around the world right now. Before 2019, we only had 5 locations for mRoot servers. However, we decided to put more NNIX instance, which means the local nodes at the to increase our footprint around the world more efficiently. So we mainly focused in AP region because we are the only root operators based in AP regions, and because that we started to collaborate with APNIC, that is also based in the AP region. And for this local nodes, we decided to use the minimum set of equipments, only one server and one switch, which means 2 rack unit size of the systems can be the one of the local nodes. this project went very slowly for the first 2 years. During the 220 and then 220 through 222 first half of that, we only had 4 locations launched. It was Brisbane, Hanoi, Guam, and Kuala Lumpur. However, after that, within this 1 year, we had 4 more locations right now, including Bangkok. One is Bangkok, Singapore, Kaohsiung, which is Taiwan, and Jakarta. These 4 are new locations launched in this 1 year. And also, there's 10 or more sites, local sites, are planned to added to the local node of mRoot. It's already in negotiation with the local hosts right now. So you can see more increase of mRoot in a year or 2. Actually, maybe 2 years or something like that. That's the deployment of mRoot right now. And you can see where the mRoot is located in the map. Outside of the AP region, there's only Paris and San Francisco. That is the only locations we have outside the AP region. And you can see that other locations are very concentrated in the AP region. Blue points is talking about the older ones, and whitish place, that is the new place launched in this 1 year. Bangkok, Singapore, Kaohsiung, Jakarta. That's our new locations. So we are constantly increasing the small node, the local nodes right now. Looking into mRoot servers in Thailand, or the root servers in Thailand. Root servers in Thailand has increased because of the mRoot, but actually was decreased. There was a root at 1 year at the 1 years before ago, but it disappeared, and right now we have mRoot in Thailand. So we have 7 letters, 11 sites, and 21 instances right now within Thailand. And Bangkok mRoot is launched in November 15th last year, supported by NNIX. Thank you very much for the NNIX. That's the root service in Thailand. And I have some figures about what has happened in the launch of the Bangkok node. Before launch of the Bangkok, mRoot creates 2 mRoot servers from Thailand. It was handled by 100% outside of the Thailand. And most of that is by Tokyo and Kuala Lumpur. It handles more than 90%. And rest of that is handled by Paris, France. So left-hand pie chart is about that. And the Bangkok node launched in November 15th last year. This is the 1-day query rate figure of that day, exact day. So you can see that the Bangkok node has receiving queries from this point, from this time. It was launched, and it took more queries from Kuala Lumpur node, which is the yellow one, and a little bit from Tokyo node. And that made about 35% of the queries are right now handled within Thailand, which means this Bangkok node. And that made, because using the Bangkok node is the very geographically near place other than the Kuala Lumpur or Tokyo, the advantage of the RTT, it has become shorter. Bangkok nodes only have 7 milliseconds or something like that, instead of 30 or 100 or those kind of size. So that was the launch of the Bangkok. And after that, there was 3 more locations has launched for en route. That is Singapore, Kaohsiung, and Jakarta. That also made some effect to the queries within the Thailand. There was Kuala Lumpur node that had that was taking about 20% of the queries derived from Thailand. However, after Singapore nodes has launched, it disappeared, and Singapore node took its place of beside of the Kuala Lumpur. The queries changed its direction to Singapore node. Other two, Kaohsiung and Jakarta, that didn't make any change to the Thailand. So today, 35% is using Bangkok node. However, 65% of queries are still handled by outside of Thailand, which means the Tokyo and Singapore and Paris. That is taking those large portion of the queries right now. I'm not sure about the how the ISPs consists in Thailand, but some large ISPs may not be in Bangkok right now, BKNX. So I made one slides to all of you to please check the locations en route right now, which locations we are using. We are in BKNX using route server. And you can check which en route locations responding to the clients of your network with this command: dig@mark m.rootservers.net with chtxt hostname.bind plus short. If the response is m-bkk1, you're using the Bangkok node. That's very good for you. And if it is not, your network may not be configured to use AS700 7500, which is the en route, via BKNX route server. So in that case, please consider peering with us at BKNX. If you're not using the route server, just contact us and make peering with us. So it's 7500 at nspixp.y.adjp. That is our contact mailing list address. And you can join us using the BKNX node. Okay, that's all for my presentation. Thank you for listening.
Hello, test. Okay. Thank you, Mr. Shinta Sato from JPRS. And the next topic is internet measurement from our speaker, Mr. Wita Laksono, Senior Internet Resources Analyst from APNIC. Please give him a round of applause. Good afternoon, everyone. Sorry, the food is so nice today. I mean, hopefully everyone not falling asleep. So yeah, thanks for Nan and everyone here who inviting us. So this is the second time for me attending Thai Node in this beautiful place, Bangkok. Last year I was here, and yeah, we had very good, the discussions, conversation with everyone basically. And this is one of the most productive events that we always have every year. So I look forward to, to talk to anyone further after this session. So to discuss anything related with the internet resource, a service that we provide, and taking any feedback for any future improvement that we can start working on. My name is Wita. I'm one of the APNIC host master. taking care of the APNIC membership and internet resource application submitted by your company, and also by the new members who join with us, and then requesting for IP address and S number for their network. So basically, my daily job is in the services department. So if you have any question about the the current policy or procedure, feel free to reach me out after the session. And yeah, this time I'm gonna share some information about the APNIC measurement. So this is basically from the labs. Labs is accessible publicly. So the intention is to provide as much information, useful information as possible for everyone, for the members, the internet communities everywhere. And yeah, we welcome any feedback or suggestion that might increase the quality, or any feedback for the future development. Yep. So okay, the labs started over 10 years ago. So the background is so we have the system, and then we start with measuring our network, and then measuring others network, and also measuring everything. So we use the script at the moment. We use the script that we put in the Google Ads. So we only capture the information related with the network, with the IP address, with the internet resource. Okay. Today, I mean, at the moment, we have like more than 50 million samples per day. So we capture IPv6, DNSSEC, and RTT. So all the information are published in the labs that accessible for everyone. Okay, now if you look at the IPv6 deployment rates in the world, focus on the orange line, the bold one, because it's Thailand. So this is this presentation is basically to motivate everyone in Thailand to keep increasing the IPv6 adoption, and also the reachability of the IPv6 network. So the explanation about this graph is in this slide. So Thailand, compare with the world and also the Asia level. So the comparison is the between the total internet users and the IPv6 capability. So Thailand is quite good. It's almost reached 50% of the total internet users. And yeah, I look forward to to help anyone here to increase their IPv6 capability. Okay, so now this is the the state of the world. In average, in the world, the figure at the moment when this sample was taken is 35%. If you look at the red circle, it shows Thailand in 48 point something%. Okay. The good ones are the green color. So those are the top, the top level. And then so those green ones are, the countries or the economies in our region, Asia Pacific. And then in the world average, so if you look at the the yellow, I mean the orange is the second level, And then the yellow is in the other, yellow is in the second level, orange in the fourth level, and red is in the bottom level. Okay, let's see the detail here. So APNIC economy is above the world average, and Thailand is included. Okay, so there are 9 of economies or countries in the APNIC region above the world average. So it's really good. And I want those economies to, not I want, but we want, you know, those economies keep increasing the IPv6 adoption. And 6 close to average, another 4 coming close, and then 5 a little bit lagging behind. So if we look at this, well, I personally, when I look at this, I always think about opportunities. This figure is actually to motivate everyone, whoever, you know, already on the 5 top or whatever in the top level, they should keep increasing, you know, the rates, and whoever in the top level, I mean in the bottom level, they need to start thinking about, okay, what we need, what they need, you know, to start working on it, to start the improvement. And as you know that, especially in the internet exchange community, people talk to each other, people supporting each other, people, you know, connecting each other, and they discuss about everything basically of the network. And based on my personal experience, you know, those conversations usually, you know, come up with some ideas, support, and person-to-person, how do you call it? Like personal, you know, relationship between the engineers. Sometimes, you know, really help on either the future development, the current troubleshooting, or you know, try to build up a proposal for the local government, for example, to support IPv6 deployment. So to you know, to give some incentive to the government, to the policy decision maker. So that happened based on my personal experience in some other economies in our region. You know, those kind of conversations are very useful. Okay. Yep. So now this one is the comparison between the population. So we know that India and China are the highest population in our region in the Asia Pacific, and that's one of the reasons why the percentage is high. And if you look at you know, other economies or other countries, they are lower than that. I think US is start growing up, I believe, and Thailand somewhere there. But again, to me, all these, you know, figures are for us, for all of us, just to put more effort and, you know, build more, you know, cooperation between us on how to help everyone to, you know, to use more IPv6, because this is for your information, the IPv4 resource in APNIC is getting lower. I mean, the undelegated IPv4 resource in APNIC is getting very low. So I really encourage everyone to start utilize your IPv6, not just announcing, start assigning to your customers, and then of course you can talk to the other you know, people or the other companies who have successfully deployed the IPv6. Because again, I'm talking about my personal experience. My background is technical engineer, sorry, network engineer. Some ISPs, they like to advertise the IPv6 block, you know, the parent block, the /32, for example, but they don't really assign the IPv6 to their end user. So when we run this statistic, we see the big block is there in the internet, but the number of users is very low. So that's the information that we would like to share in this lab to build awareness to everyone. Okay. All right. Yeah, this is in the Asia Pacific. In the so the South Asia, including India, they have a quite high IPv6 capability rate. So again, Southeast Asia, Southeast Asia is our sub-region, including Indonesia, Thailand, Malaysia, and so on. So we have 30% average rate at the moment. Okay, hopefully after this session, we can increase it. So Asia only 40% and Thailand nearly 50%, like I mentioned earlier. Okay, now this is the position in the Southeast Asia. So Thailand is almost 50%. So the graph is, so the first three color on the top, it shows very good progress. So they're increasing. And then somehow Myanmar, Singapore, for some reason, it was dropped at the time when we capture, the data. So probably they have like a not technical issue, but they have some consideration to probably reduce the IPv6 assignment to their user, maybe. Honestly, I don't have that information yet. Yeah, so Indonesia is quite below. They have large. I think they are the largest population in our sub-region, Southeast Asia. So they need more encouragement. I'll be there for the IDNOC on July. So I hope to see everyone there, so then we can push the Indonesian to increase IPv6 deployment as well. Singapore, yeah, Indonesia and Singapore is quite low at the moment, and Philippines. I think some people are from Philippines here, so let's work together. Okay. Yeah. Now this is the service providers in Thailand. So anyone from advanced company here? Anyone? No? How about from through online? No one? Okay. Justel or Ace Fiber? Because I want to give something. Yeah, so yeah, they are the largest IPv6 deployment rates in Thailand. So this is the real data. You can visit. You can see it in the APNIC labs. So next year, make sure that your network, your company is listed here. So we have the whole year to do some work. Is that right, Nan? Come on. Okay. Yeah. So advanced 94%, through online 70, Fiber 67, and Justel 65. Very good, above 50%. So in the national level. Okay. Yeah. Some other measurements that we have in our labs. ROV or ROA, everyone knows about that. Route origin validation, DNSSEC, use of PDNS, public DNS, IPv6 extension header. There are more information on the stats. Feel free to go there. And let's say talk about each item on the next slide. So this is the route origin validation related with the RPKI deployment. So this is to secure your IP address prefix announcement. Everyone knows that this is to basically to prevent the route hijack. And yeah, I think many IXPs in Thailand already implement the the RPKI and route origin validation. And so if you look at the the diagram on the left hand side, through online, they have a large number of people valid, which is good. So the motivation to show this figure again is to motivate everyone, because next year you want your IXP to be there, right? Yeah. So, and not just because of that, of course, but to improve the quality of your network. Okay. And okay, and this is the DNSSEC. This is quite a interesting. So Siam data has more than 94% of the DNSSEC validation. You might argue that it's only like 137 samples compared with other who has like more than 206 samples, or even like 4,522 samples. So this is more about the quality of the DNSSEC validation process. And we will also provide a further information or more data in the future, I believe. And so this is the data that we have at the moment. And another interesting information is public DNS service. Some provider, when they receive a DNS query from their customer, they forward the query to other public DNS service. So for some reason, they do that. It is well, yeah, it is okay if they, because maintaining the DNSSEC needs a more effort than just the normal, the just general DNS, and some of them may not have enough resource. And again, this is the opportunity for everyone here in Thailand. This is specifically for Thailand. Okay, this is the opportunity for ThaiNOC and everyone here, BKNIX and everyone here, to probably organize the DNSSEC training. Yeah, very good opportunity. We have all the experts here. So start helping others to secure their DNS. Many cases happen related to the DNS service or DNS query, and when someone went to when someone accessed a website, they was directed to the fake one, that kind of things. Yep, and yep, this is the IPv6 extension header problems. If we look at the ACE, so they have we capture 508,000 samples. The V6 fragmentation drop rate is only like 2.2%. So this is when you run IPv6, the communication between the network who announced the IPv6 with the destination, there is some MTU that need to be communicated, because sometimes in the middle, the IPv6 header is not, I mean, this is too big for one network in the middle. And then, that network will, that point will send back will notify the, the source, and then asking to reduce the MTU size. One of the alternative, one of the power communication is to enable the ICMP, so then we know what happened in the middle, and then the source will know what happened in the middle, so they can keep changing the size of the packet header, IPv6 packet header, to be able to to pass through the network who has a lower size in the middle. Okay, now I'm going to talk about the other tools that we also have in the labs. So we have DES, REX, and NetOx. Okay, DES provides some information about the suspicious traffic coming to your S number. So from here, we can see how many percent of the traffic, of the bad traffic that try to come to your network. This data is captured from the S number and prefix. So the status combines between the combination of BGP, Internet Routing Registry, and RPK data to show the inconsistency. So for example, if someone tried to announce someone else's IP address illegally, then it might be captured. Yeah. And then it also provides the alerting system. So you can enable the alerting system if someone try to do something to your S number, then you'll get a notification. Yeah. Okay. All right. And yep. So the last one is the REX, Resource Explorer. So this provides statistic that you can download. So for example, if you want to see, the IPv6 deployment of of any network, then you can grab it from here. So download as a CSV file, for example. And this is a good how to call it, a source for your presentation, for example, to convince your management to start deploying IPv6 compared with other competitor, for example. Okay, yep, this is the further explanation from the graphs. Yep, networks is basically capture from, this is the another presentation of the source data from RIPEStat. So we basically provide more information, add more information in the tools. Okay, so this is the last information, which is also very important for everyone. So I would like to see everyone in the next APNIC conference in Kyoto, Japan on September. Everyone is invited. And let's say continue the conversation and join with the activities there. So thank you so much.
Thank you, Mr. Wita Laksono, for the informative talk. Let's move to the next session. And the next session is the C5 Spotlight on Thailand Data Center Market by Miss Vivian Wong, Research Analyst from BYTE. Please give her a round of applause.
Hi, good afternoon, everyone. Shift gears a little. So my presentation is on the C5 with a spotlight on Thailand's data center market. So it's my pleasure to be here today. Thank you to the BPF2023 team for having us to share our research. My name is Vivian, and I'm a research analyst covering the Southeast Asia markets within the team. So BYTE, we are a market research firm that specializes in data centers. So our main offering is an analytics platform that tracks over 6,000 data center facilities across APAC, EMEA, and also the US. So currently we are servicing clients who are data center operators, telcos, investment funds, private equities, and increasingly data center suppliers within this industry. So without further ado, so I'll first be going through an overview of the regional data center market, followed by zooming into the Thai current landscape, supply and demand trends, hyperscale activities, and wrap up with our perspective on the future of the regional market. So to start off, what you're seeing now is the aggregate megawatt IT capacity in Singapore and across C5. So C5 refers to Indonesia, Malaysia, Thailand, Philippines, and Vietnam, as you can see on the screen. So Singapore has been a leader in terms of the IT capacity. And this is also related to its status as a preferred hub to serve regional hosting needs because there's little or no natural risk, stable political environment, availability of infrastructure. But however, in recent years, due to the rapid digitization across the region, and also accelerated by the pandemic, people are moving closer to where the people are. So this is what we call the decentralization, where people move towards the host country for improved cloud services, performance, and latency. And there's also the impact of Singapore's moratorium, whereby currently they are running a pilot data center for only about 60 megawatt that will be added to the market. So operators have now looked towards like the region for their hosting needs. There's also the incoming data sovereignty regulations, whereby certain data will now have to be stored within the shores of the nation. And finally, because in Southeast Asia, there's the availability of land and power, and in some cases, renewable energy. So I think all of these factors combined has actually kickstart the developments within the Southeast Asian nations. So as we can see, for markets such as Indonesia, it has grown by more than 5 times since it was in 2020, which is represented by the bar in purple. So for Thailand, so far we've seen a more steady growth, and currently it's at about 200 over megawatt. So this is how BYTE records the Thai data center market. So it's at a total aggregate supply of 207, of which 49 is live, 33 megawatt is under construction, 106 is committed, and 20 megawatt is in the early stage. So in terms of how we define the capacity, live and under construction is self-explanatory. So on the committed, we refer it to as projects which land and power are secured, and we think that they have the necessary resources to bring the project to success. So in terms of the early stage, refers to projects that are announced, but we are still monitoring very closely to see if they have the necessary resources, presence of an anchor tenant that will allow it to kickstart the construction. So among the live co-location facilities in Bangkok, Bangkok is currently at a 28% vacancy rate, and Bangkok is also predominantly a co-location market with a small proportion of self-built that has grown over the few years because of the entry of AWS, availability zone in the Eastern Economic Corridor. So this is how we have mapped the Thai data center markets. The dots that you see here represents all of the data centers. So the pink refers to co-location facility, purple refers to the self-built. So in general, most are still centered within Bangkok, and we have seen clusters in Central, North, Samut Prakan, and the Eastern Economic Corridor. So we will not be able to share every single data center that we are covering, but because as a research analyst, we verify every single data center projects in the market. That's why we conduct regular market inspections. So these are some of the real photos that we have captured. So in terms of like the developments in Central Bangkok, Kelly House has actually finished their construction of this facility that is expected to come live with 4.3 megawatt. And not on this slide, there is also STT GDC that has partnered with Fraser Property on their Bangkok 1 facility that came live in the recent years. There's also Singtel, who has partnered with Gulf Energy, AIS, to build a campus of 40 megawatt. And there's also a domestic player, ProEarn, that's also groundbroken on their 6 megawatt data center facility. And in the Samut Prakan area, it's slightly more interesting. So these were the two sites that we've seen last year. So ATIX Everywhere, previously, they have acquired this site from Genesis DC, and Bridge Data Center is under Chin Data. So they have acquired this facility BKK01 from WH8. So these are all data halls that are built within logistics facilities. And not on this slide, we have also through IDC and NTT who have campus within the Samut Prakan or Bangna area. And in North Bangkok, there's One Asia. So this was their construction site that we saw in November last year. So they're building 14 megawatt over 2 buildings, and they are targeting to bring this facility live by the end of this year. And finally, in the Eastern Economic Corridor, Supranaut has actually their facility since 2017. And following which in 2021, 2022, AWS has started their construction of their 3 sites. They are located in Rayong. So these were the progress of construction that we have tracked. So as you can see from all of the real photos, Bangkok is really a very busy market. So this is another IT megawatt supply chart, but we have broken down the capacity into the live, under construction, committed, and early stage. So this is clear to see since 2016, there's been an increasing proportion of the committed and early stage capacity. So assuming that all of these projects built out successfully, Thailand is expected to hit 207 megawatt. So you might wonder, Thailand is only currently at about 49 megawatt. Isn't it a very large number to project, right? So we like to look at this in terms of the perspective of the megawatt per million capital. So if we do the numbers, Thailand is currently at 2.98. So if you compare it to Malaysia, Malaysia is 29.8. So even with the full build out of 200 over megawatt, there is still capacity for Thailand to grow even closer to its competitor in the region like Malaysia, right? And comparing to tier 1 markets, so the average across Singapore, Hong Kong, Sydney, and Tokyo, they're currently at 117. And if we were to compare it also to the hyperscale infrastructure, currently Thailand has seen AWS and Google who have announced their entry into the market. And Alibaba, Tencent, and Huawei have all deployed capacity within the city. So this brings it even closer to Malaysia, who has most of the hyperscale entry within the market. So Philippines and Vietnam, we can see that there are still many unchecked boxes. So I think this speaks volumes of the potential growth trajectory that the region can be on and to fill up the gap. So finally, this is a slide summarizing most of the announcements within the last 1 to 2 years in the region. So Southeast Asia has been very busy, seeing very large announcements, but we think that this is likely to be the way going forward because there is simply a growing potential within the region, which many operators are looking to capture. So we hope that our presentation has gave you an insight of the dynamic market, and feel free to connect on email, LinkedIn, or even at the event after this if there's any question, and we're happy to discuss them. Yeah. Thank you everyone for your time.
So let's move to the next topic. The fourth session in the afternoon is the landscape of Chinese IXP from Mr. Shicong, Chang from NNIX. Please welcome Mr. Zhang.
Hello, everyone. I'm Shicong from NNIX of China. Another name is IX.cn. Today, my topic is software-defined exchange controller for IXPs. This is the overview of NNIX. China has approved 4 IXPs since 2019, distributed in East China, South China, and West China. Shareholders are basically composed of 3 Tier 1 carriers, internet enterprises, and local enterprises, guided by Chinese government to keep neutrality, justice, and openness, performing like a semi-public service organization. We are here, the first one, located in Hangzhou near Shanghai. NNIX is approved and supervised by Ministry of Industry and Information Technology of China. We have more than 50 employees and have been running for nearly 3 years. The 9 shareholders, 3 Tier 1 carriers reach 70%. You know, China Mobile, China Telecom, China Unicom, Alibaba, Wasu, NetEase, and the 3 local enterprises. We have connected 180 enterprises. Capacity of the access port has reached to nearly 10 TB, while peak traffic has reached to 2.5 terabits per second. The challenges of building NNIX in China. Because we are the first IXP in China, there is no local references. Expectations are high in Chinese in the internet industry. Needs to solidify the experiences and shares with local IXPs. The building goals end-to-end equipment management, one-click orchestration of all services, autonomous and intelligent. The existing controller, weak multi-vendor device compatibility, IXP classic service orchestration is not supported. Customized development is long and costly. So this is a common problems in the build of IXPs in China. So we SDX controllers independently through 2 years exploration, self-developed and launched the first IXP brand of China, SDX controller, built automation and intelligent capabilities for network interconnection, cloud interconnection, and computing awareness. The computing awareness is a new technology with the IT industry. The IETF has recently formed a new workshop called CATS. The CATS is short for Computing Awareness Traffic Steering. And realize network controllable and construction standardizing of IXPs in China. Enable IXPs online quickly. So this is a SDX controller in the middle of the key features of the SDX controller. The first is abundant management capabilities. Multi-vendor devices, public cloud APIs, computing awareness gateway, various devices in each IXP. The second is powerful virtualization capabilities. Enterprises can remotely control IXP equipment at any time, supporting logical isolation between enterprises. The third is flexible orchestration capabilities, low code, dragging to implement service orchestration and support personalized services in different IXPs. The fourth is O&M capabilities, automatic traffic scheduling to maintain the best network quality. And the fifth, computing awareness network. heterogeneous computing resources management, perception, and scheduling. About the performance, service orchestration cycle from weekly to hourly, so from days to minutes. Concurrent processing capacity about 300 plus orders one time. Troubleshooting time from hours. The first is abundant management capabilities. It supports physical devices, such as different types of routers, switches, and computing awareness gateways from different manufacturers, such as Huawei and H3C, as well as majority public cloud API integration capabilities, such as Alibaba Cloud, Huawei Cloud, and the Tencent Cloud in China. Second is flexible orchestration capabilities. Extracting the capabilities of each device as the most basic atomic capabilities. You see the left, the atomics. The atomic capabilities are combined into complex and diverse services scanners by dragging and connecting. And the complex service can be activated with only one click. Just click this button and type in some parameters and execute. So it's running. And the service is activated. The next is powerful virtualization capabilities, abstracting devices into isolated virtual ports, virtual routers, and virtual switches for customer self-use. Customers can create their own virtual IX network. First, create a vPort and deliver the configuration. Then the vPort is online. Second, create a vRouter and deliver the configuration. Third, configure routing policies and join open peering. So we can order more services such as selective peering and multi-cloud interconnection through this system. Then is the intelligent O&M capabilities. Improve IX networks O&M efficiency by high precision and real-time acquisition, analysis, and automated strategy delivery. The SDX collects and analyzes network data in real time and monitors link quality. You can see from the graph. The link 1 is congested. SDX senses that the link quality is abnormal and issues a traffic scheduling policy. Traffic is successfully switched into link 2 and the SDX aware the quality returns to normal. Next is evolution for computing awareness networks. The computing awareness is very difficult to get because there are many different chips like CPU, GPU, and professional AI chip. So it's very hard. There are many technology details in the awareness network. So this is just an overview by 4 steps. First, access heterogeneous computing resources. Second, interconnection to computing resource interfaces. Third, combine networking orchestration with computing. Next, provide integrated computing power services. This is a procedure. Thanks.
Mr. Shicong Chang, your slide is very beautiful. Animation make us easier to understand. And the last one from the technical session is the Mr. Masataka Mawatari from JPIX with the topic to maintain IX network clean and stable. Please welcome Mr. Masataka.
Thank you for introduction. My name is Masataka Mawatari from JPIX. Yeah. So I feel very happy to have this opportunity to speak to you here. And the title is to maintain IX network clean and stable. So I'd like to share our experience about hygiene of IX network. So IX providers are doing keeping hygiene of IX network. So before the main agenda, let me introduce JPIX network. So we are operating 3 networks in Japan. The first one is JPIX Tokyo, and the second one is JPIX Osaka. And third is the newest one, so it's called JPIX Fukuoka. And also JPIX has partnership with overseas internet exchanges for providing remote peering service between IXP providers. So we are doing preparation of service expansion of JPIX in Thailand with Telehouse Thailand team. So yes, this is the agenda of my presentation. I have 3 agendas. First one is introduction of background and IX network. And second is JPIX experiences. And third is the final lessons learned and conclusion. Yes, first of all, I'd like to explain what internet exchange is. So as you know very well, so internet exchange is a network infrastructure for exchanging internet traffic between networks. And this diagram is very simple, showing internet exchange network. So, but practically speaking, the internet exchange network consists of more pieces of equipment compared to the previous slide. So we are operating multiple IX switches and DW systems, but also we are operating some servers. For example, BGP router server for IX members, and we have also TCP dump servers and ping check servers for monitoring and network monitoring and so on. So maybe you were thinking this network with network architecture like this, it's not so complicated and complex, but operating enormous big broadcast network is very hard to operate. So let me explain when a new IX customer connect to JPIX, and this is a procedure for IX customers. It's a very similar procedure to other IX providers, I think. So first one is on the customer side and the IX side. We will provision from lower layer to higher layer, laying cross connect and the port configuration and the route server and BGP router configuration and patching the fiber to equipment. And after the physical preparation, the customer router will connect to quarantine LAN. So quarantine LAN is another network different from production LAN. The quarantine LAN is for checking connectivity between BGP router on customer side and IX switch. And the customer router needs to be checked by several tools before moving to production LAN. And after confirming connectivity between router and IX switch, finally, customer router will be moved to production LAN from quarantine LAN. And after that, customer router will be able to peer with other members and our route servers. And today's my presentation main topic is related to TCP dump check. And everybody knows TCP dump tool. And let me introduce, let me explain, briefly explain about TCP dump check. IX provider check the unacceptable packet and unwanted packet from customers. So as I said before, so IX providers need to keep hygiene of IX network. So every day and every time, so IX engineering team is checking the network by TCP dump tool. So and I like to share my experience with in JPIX. So this slide shows switch maintenance JPIX had performed in the past. So JPIX is operating IX network by multiple multi-vendor IX switch. And the JPIX is working for moving our IX network to a single vendor network. So in terms of this switch maintenance, the in I learned, I noticed before that the customer router was sending BPD packets and had enabled spanning tree protocol on customer A router, the port connecting to JPIX switch. But other router in this slide, customer B router and customer C router and our TCP dump server couldn't confirm customer A router was sending BPDU packet. So in this switch maintenance, JPIX network team had replaced one of IX switch from vendor A to vendor B. And after the replacement of one of switch, this from vendor A to vendor B, so JPIX network team confirmed TCP by TCP dump server, customer router was sending BPD packet, and at this moment, the JPIX network team noticed it by TCP dump checking, and there is several event related to this IX maintenance. This is first experience on customer side. The customer B router has started to receive BPD packet from customer A router, and customer B router started logging. As you can see this slide, and the customer B router received a BPDU packet, and this log means the old packet coming from other routers, and the log message means log. There is a log, and the unknown protocol drop counter has incremented. Auto packet means BPD packet in this case. And this is second case happened on other customers. Customer C router's MAC address disappeared from the MAC address table. IX switch, new IX switch migrated from old one. So, and due to lower problem and BGP sessions between customer C router and our JPIX route server went down. But at this time, the IX port physical status was still linked up. And after this happening, we confirmed this symptom. It seems that switch owned by customer C was placed between JPIX switch and customer C router, and seems that the error disabled happened due to BPDU guard on the customer C switch, and the error disable has make network down. And other investigation of from JPIX network team, the switch by vendor B forwards BPD packets transparently by default behavior. But in other hand, switch by vendor A discarded BPD packet by default. So there is a default behavior differences between vendors. And I like to start closing my presentation by lessons learned and conclusion. This is a lesson learned from this experience with our IX switch maintenance. The first lesson learned is that understanding default behavior of equipment is so important, especially for multi-vendor network operations. And the second one is reviewing the network layout for connecting TCP dump servers is also important. The closer network distance between customer router and the TCP dump checks servers, it's the better. And this is the final slide. This is a conclusion slide. I have two conclusion points. The first is IX network is becoming even more enormous and consists of more pieces of equipment than before. This means it's relatively hard to keep hygiene of IX network, but I really would like to make this situation improved with IX customers. And the second conclusion is IX has to do day-to-day housekeeping in IX network for protecting our customers. And I think this needs cooperation from IX members as well. This is, yes. Yes, that's all of my presentation. Thank you for listening. Thank you for your attention. Thank you.
Masataka-san. And I would like to thank you all our speakers in the technical session.